The Moon's orbit is almost perfectly circular. For a captured object, that's physically impossible. And that's only the beginning. There are 6 things about our Moon that mainstream science still struggles to fully explain. Not conspiracy theories, just physics that doesn't quite fit. 6 puzzles, each one stranger than the last, and by the end they'll all connect into a single story you won't forget. Let's start with puzzle number 1. Puzzle 1. The impossible orbit. When an asteroid or any object gets captured by a planet's gravity, it doesn't just settle into a nice, neat circle. That's not how orbital mechanics works. Any object captured by gravity follows a highly elliptical orbit. This is basic orbital mechanics, confirmed by every space mission since Sputnik. The object keeps its original momentum, so it swings close to the planet, then flies far away, tracing a long stretched out ellipse. Look at any comet or near-Earth asteroid. Their orbits are wildly stretched out. Some swing past the Sun and then fly out past Jupiter before coming back. This is what gravity capture looks like, always elongated, always eccentric. But the Moon's orbit? It's nearly a perfect circle. Its closest approach to Earth, the perigee, ranges from 356 to 370,000 kilometers. Its farthest point, the apogee, sits between 404 and 407,000 kilometers. Think about that for a second. Every captured object in our solar system has a stretched, lopsided orbit. Every single one except the Moon. Now, to be precise, the Moon's orbit is not a perfect circle, it is an ellipse, with about a 10% difference between closest and farthest approach. But for an object this massive, that level of circularity is remarkably unusual. This fact has fueled plenty of speculation over the years, but instead of reaching for exotic explanations, let's ask a better question. Is there any natural process that could make this happen? Computer simulations, including models published in peer-reviewed astrophysics journals, show something remarkable. If you place multiple large asteroids into different elongated orbits around Earth, they immediately start interacting. Their gravitational fields pull and push each other, they collide, they merge. Within 20 simulated years, the first collisions happen. Asteroids smash into each other and fuse into larger bodies. One of the resulting objects settles into a nearly circular orbit. The collision itself absorbs the excess orbital energy. So here's the twist. The Moon's surprisingly circular orbit isn't evidence that something strange put it there. It may be evidence of something violent. After 80 years of simulation, most surviving objects have settled into stable circular orbits. Some were ejected from Earth's gravitational pull entirely. But of those that stayed, 4 out of 7 ended up circular. One had exactly the same 10% deviation as our Moon. So the Moon's near-circular orbit isn't unexplainable after all, but it implies something dramatic. It suggests the Moon wasn't gently captured. It may have been forged in orbital chaos, built from the wreckage of many smaller bodies smashing together like a cosmic snowball. That's puzzle 1. Reframed. The orbit isn't magic, it could be evidence of catastrophic collisions. Now let's move to puzzle number 2, the hollow Moon. During the Apollo 12 mission in 1969, NASA deliberately crashed a 2.5-ton rocket stage into the Moon's surface. The seismographs they had placed earlier recorded something unexpected. The Moon vibrated for over an hour. NASA scientists described it as ringing like a bell. But wait, if the Moon rang like a bell, does that mean it's hollow inside? That's what many people assumed. The real answer is more interesting. The Moon can't literally ring in a vacuum. There's no air. What the seismographs measured were vibrations traveling through solid rock, and long-lasting vibrations actually suggest the opposite of hollowness. A cavity would dampen vibrations. Extremely dense, uniform material transmits them efficiently. It's the same reason certain stones on Earth produce a ringing sound when struck. They're incredibly dense and uniform inside. The Apollo seismic data, analyzed by NASA's passive seismic experiment team, actually points to a moon that's denser on one side than expected. But there is a real mystery here. The moon's average density is only about 3.5 grams per cubic centimeter. That's dense basalt. But for the surface to vibrate the way it did, you'd expect a density closer to 4.5, more like titanium. So what's going on? If the surface is denser than the average, then the interior must be less dense to compensate. The moon isn't hollow, it's likely porous in places. Dense, compacted material on one side, lighter, more porous rock on the other. And that asymmetry leads us directly to puzzle number 3. Notice the pattern. Each puzzle doesn't just stand alone, it feeds directly into the next one. The density problem leads us straight to the strangest map in astronomy. Puzzle 3. The one-sided seas. If you look at the moon, you'll notice the dark patches, the so-called lunar seas or maria. About 80% of them are on the side that faces Earth. The far side? Almost none, just craters, thousands and thousands of craters. Underneath each major sea, orbital instruments, including NASA's Grail mission in 2012, have detected mass concentrations or mascons, regions of abnormally high gravity hidden beneath the surface. In 1968, researchers Muller and Sjogren first proposed that these mascons could be the remains of metallic asteroid cores buried during impacts. That hypothesis was initially set aside. At the time, researchers weren't convinced asteroids with iron-nickel cores could produce those specific gravity signatures, but decades of new data have reopened the question. Here's something to picture. An asteroid 500 kilometers wide doesn't just leave a crater, it melts through the crust entirely. Imagine a cannonball dropped into a lake of rock. The accretion model makes this straightforward. If the protomoon was sweeping up debris from its inner orbit closer to Earth, large asteroids would preferentially strike its Earth-facing side. Any object over 500 kilometers across would melt through the surface, creating a sea of liquid magma, and its metallic core would stay buried underneath, a mascon. Magmatic rock formed this way has a density of about 5 grams per cubic centimeter, even higher than titanium. This would explain the seismic readings, the mascons, and why those lunar seas cluster on the same side. The bombardment came from one direction. 3 puzzles down, 3 to go. And the next one is perhaps the most well-known lunar oddity of them all. Puzzle 4. Why does the moon always show us the same face? You've seen the moon your entire life. But have you ever noticed it never turns? You've never seen the other side, not once. Why? The moon rotates on its axis at exactly the same rate it orbits the Earth. This is called tidal locking. The standard explanation is that over time gravitational friction gradually synchronizes the rotation, and that's a well-established mechanism, but it doesn't fully explain why the heavier side faces us. The side with the mascons, the side loaded with dense material and solidified magma seas, is significantly heavier, and that heavier side is permanently locked facing Earth. It's like a weighted die. The dense side sinks toward the gravitational source and stays there. So tidal locking may not be some coincidence. It could be a direct consequence of the moon's lopsided construction. All that bombardment from one direction created a gravitational imbalance, and the heavy side naturally fell toward Earth and locked in place. And remember those seismographs that detected the hour-long vibrations? They were placed on the near side, the dense side. That's why the readings were so strong. On the porous far side, the signal would likely have been dampened. See how all 4 puzzles keep circling back to the same idea? Orbit, density, seas, locking. 4 separate mysteries, potentially one explanation. Now it gets stranger. Puzzle 5. The moon is the wrong size. Look at any other planet in our solar system. Jupiter has dozens of moons, but even Ganymede, the largest, is a tiny fraction of Jupiter's mass. Mars has 2 moons, Phobos and Deimos. Phobos is about 22 kilometers across. Deimos is even smaller. They're likely captured asteroids, tiny pebbles compared to Mars. Now look at our moon. 3,474 kilometers in diameter, one quarter the size of Earth, one quarter the size of its planet. No other rocky world in the solar system has anything remotely like that. Earth's moon is, by proportion, an outlier. The leading explanation in mainstream science, the giant impact hypothesis, says a Mars-sized body called Theia slammed into early Earth and the debris coalesced into the moon. It's elegant, it's dramatic, and it has some unresolved questions. If the moon formed from the same material as Earth's mantle, their compositions should be nearly identical, and in some ways they are isotope ratios of oxygen, for example, match closely, but the moon's overall density is significantly lower. Earth averages 5.5 grams per cubic centimeter, the moon just 3.34. If a Mars-sized body hit Earth and sprayed mantle material into orbit, you'd expect the resulting moon to have a similar iron content and density, but it doesn't. The moon appears to be iron poor, as if it was assembled from a different recipe. Same ingredients should mean same result, but Earth and Moon don't match, so either the recipe was different or the kitchen was. But if the Moon wasn't blasted out of Earth, if it was assembled in orbit from diverse captured asteroids, each with its own composition, then the density mismatch would make sense. Different ingredients, different final product. 5 puzzles, 5 possible answers that all point to the same kind of event, a catastrophic period when Earth's orbital neighborhood was full of debris. And that brings us to the final puzzle. This last puzzle is different from the others. It doesn't come from physics or geology, it comes from human memory. Puzzle 6. The time before the moon. Multiple ancient cultures. Greek, Roman, Columbian, African contain references to a time when there was no moon in the sky, the pre-Saline era, a moonless earth. The Greek writer Prosalinos recorded that the people of Arcadia claimed to have inhabited the land before the moon appeared. Roman poet Ovid mentioned a time when the moon did not exist. These references, while not scientific evidence, are intriguing because they span multiple unconnected cultures. Now, to be clear, ancient texts aren't physics data, they are cultural memory, passed through generations, subject to distortion. But the question they raise is worth considering. Could the moon have arrived late enough for early civilizations to notice? And here's an unexpected detail from the simulations that makes this question more interesting than you might think. Without the moon present, Earth can capture and hold many objects in orbit. Large asteroids can circle the planet for years, even decades, but the moment a large moon exists, everything changes. Simulations show that any asteroid on an elongated orbit around Earth gets its trajectory wildly disrupted every time it passes near the moon. The moon acts like a gravitational bouncer, flinging intruders out of Earth's orbit or redirecting them. The process that might take years without the moon finishes in months when the moon is present. This suggests something interesting. If large asteroids once orbited Earth for extended periods, as some geological evidence hints, then during that time the moon may not have been there yet. The moon could have come later. But what about the idea of 3 moons? Could Earth have had multiple? The physics has a clear answer, and it's surprisingly violent. Place 3 moon-sized objects on different orbits around Earth, and within a year, 2 of them are gone. When massive objects approach each other in orbit, the lighter one gets a gravitational kick and flies off into deep space. The mathematics is unforgiving. Multiple large moons around Earth is not a stable configuration. Perhaps for a few chaotic months during the assembly period, multiple large bodies coexisted in orbit, but not as stable long-term companions. The moon we have is the survivor. Some ancient flags and symbols are interesting in this context. Many Ottoman-era emblems show a crescent moon with a star inside the crescent. Not next to it, inside it. One interpretation: The star is the flash of an asteroid impact on the moon, as seen from Earth. That's speculative, of course, but it raises a fascinating question: how much of what ancient people recorded as mythology was actually observation? Now let's step back and look at the whole picture. Because when you line up all six puzzles, something extraordinary emerges. Not a collection of unrelated oddities, but a single, coherent timeline. Phase 1: a catastrophic event fills Earth's orbital neighborhood with debris. Perhaps a destroyed planet, perhaps a close encounter with a rogue object. Something that scattered enormous amounts of rocky and metallic material throughout the inner solar system. During this period, Earth has no moon. Phase 2: Earth begins capturing asteroids. Without a moon to clear them, dozens of large objects settle into elongated orbits. Some fall to Earth, others keep circling. Phase 3: the collisions begin. Orbiting asteroids smash into each other, merge, and grow. A dominant body emerges, our proto-moon. Each collision absorbs orbital energy, gradually circularizing its path. Phase 4: the moon reaches critical mass and begins clearing the neighborhood. Large asteroids from inner orbits slam into its Earth-facing side, creating the Maria and embedding their metallic cores as mascons. The far side gets peppered with smaller craters but no seas. Phase 5: the asymmetric mass distribution locks the heavy side facing Earth. Tidal forces complete the locking. The moon becomes the stable companion we know today, still bearing the scars of its formation on its face. 5 phases, 5 explanations, and every single one reinforces the others. But there's one more implication, and is the one that keeps researchers up at night. Phase 6: the moon, now massive and gravitationally dominant, acts as Earth's shield. It flings away incoming objects or absorbs them. The bombardment era ends, the night sky clears, and a new, calmer chapter of Earth's history begins. Now, the most provocative part of this narrative: if the ancient records of a moonless sky reflect any kernel of truth, it would mean the moon's assembly wasn't billions of years ago. That's a radical idea, and most planetary scientists would disagree. But the question itself is worth asking. And our solar system itself may hold clues. There are patterns out there that suggest something big happened, and not just to Earth. Now I want to be clear about something. None of this requires aliens or supernatural engineering. What it describes is something that physics can account for, a solar system that went through a violent rearrangement, and we may be living in the aftermath. The alien hypothesis is tempting because it explains everything and nothing simultaneously. Can't explain the orbit? Aliens. Can't explain the density? Aliens built it. But that's not how science works. You look for the simplest explanation that fits the data. What we've done instead is show that every single one of these 6 puzzles has a physically plausible answer, and they all point to the same kind of event: a catastrophe that seeded Earth's orbit with debris, from which the moon may have been born. But there's one more observation that quietly fits this picture, something people have photographed but rarely discuss. Large shadows have been photographed passing over the moon's surface, not from any known satellite or spacecraft. Within the accretion framework, there's a straightforward possibility: remnant asteroids on highly elongated orbits, with their closest approach skimming just above the lunar surface. Not alien ships, possibly leftover rocks from a period of heavy bombardment that hasn't entirely ended, echoes of the same process that may have built the moon in the first place. So let's take a final inventory. Puzzle 1: the near-circular orbit, potentially explained by collisional energy absorption during multi-body assembly. Puzzle 2: the bell-ringing vibrations, explained by extremely dense homogeneous surface material. Not hollow, dense. Puzzle 3: the one-sided seas, explained by directional bombardment from inner orbits. Puzzle 4: tidal locking, explained by the mass asymmetry that same bombardment created. The heavy side fell toward Earth. Puzzle 5. The anomalous size, explained by gradual accretion from diverse captured bodies rather than a single giant impact. And Puzzle 6. The moonless ancient sky, a tantalizing hint, if not proof, that the moon's formation may be more recent than we assume. What makes this framework compelling isn't any single piece, it's that every piece supports every other piece. The orbit explains the collisions explain the density explains the locking. It's not six separate arguments, it's one. And if the moon was assembled from orbital debris, the biggest remaining question is what caused the debris in the first place? What broke apart out there? That's a question planetary science is still working to answer. We look up at the moon every night and see something comforting, something that feels eternal and unchanging. But the physics tells a different story, a story of collision, assembly, and a night sky our ancestors may barely have recognized. The moon isn't a mystery that requires supernatural answers. It may be the largest piece of evidence visible from Earth, a witness to a catastrophe that reshaped our corner of the solar system. And every time you look up and see its cratered face staring back at you, always the same face, always the heavy side, always the side that took the hits, remember, you may be looking at the record of an event that built the world you live in. 6 puzzles, 1 framework,